Hey, this is Dr. Benton, and I wanted to go over the answers to our Unit 5 Atmosphere Vocabulary slides. So, first of all, don't watch this unless you've already completed the slides. The learning experience is not from me giving you the answers, it's from you finding out the answers, the discovery part. And so you're responsible for the discovery, not me. What I'm going to do is go through the slides and ask you questions as we go to see how well you do, to see how well you did on your slides. Hopefully we know some of these answers by now. And these are the words from the first 3 standards of our unit, first 3 of 5. The first standard is talking about the atmosphere, atmospheric layers, including ozone, including greenhouse. And we went over this that first week or so of our break. So first, what do we call all of the gases surrounding the Earth? We call that the atmosphere. And here's a picture of the atmosphere. What do we call the lowest level of the atmosphere? It's the one where we live in. It's the one we call that the troposphere. The troposphere is the layer where we live, the bottommost layer. Above the troposphere is the atmospheric layer where we find the ozone layer. We call that layer the stratosphere. The stratosphere there contains the ozone layer. What do we call the middle layer of the atmosphere? It's between the stratosphere and thermosphere. It's where meteors burn up on their way to Earth. We call that the mesosphere. The mesosphere is where we see shooting stars. It protects us from asteroids. What do we call the atmospheric layer between the mesosphere and the exosphere, where harmful solar radiation is blocked and it creates the aurora borealis? We call that the thermosphere. And in this case, ultraviolet radiation we said was down in the ozone layer in the stratosphere. Here we're talking about other types of radiation like gamma rays and X-rays, things that are way more harmful than UV rays. What do we call the outermost layer of the atmosphere? It's the edge of space, the border of space. This is where most of our satellites orbit. We call that the exosphere. And so here in this picture you can see that they have stars because that's practically the end of our atmosphere. Some people include exosphere as part of the atmosphere. Some people say there's only 4 layers. It doesn't matter for us. What do we call the part of the stratosphere that blocks that ultraviolet radiation? We call it the ozone layer. The ozone layer blocks ultraviolet radiation. The most dangerous stuff gets filtered out. Some of the lower wavelength ultraviolet radiation can make it to the surface, which is why we still get things like sunburns and skin cancer. What is the most abundant gas on Earth, making up 78% of the atmosphere? We call that nitrogen. Here we can see liquid nitrogen used to refrigerate things, to flash freeze things, and that's 78% of the gas on Earth. The second most abundant gas on Earth makes up 21% of the atmosphere. Do you know what it is? It's oxygen. And here we see people receiving supplemental oxygen because oxygen is the gas we breathe. Animals need it to survive. What do we call the natural process in which the atmosphere absorbs heat to help keep the Earth warm? We call it the greenhouse effect. Remember, outer space is really, really cold. The radiation itself is warm, but it's freezing on the moon. It's freezing on Mars. Our atmosphere acts like a blanket to keep that heat in. And specifically, what do we call the gases in the atmosphere that absorb that heat to help keep us warm? We call those greenhouse gases. Greenhouse effect caused by greenhouse gases in the atmosphere that absorb that heat and keep it from escaping into the cold of outer space. What is the main greenhouse gas being produced by humans as we burn fossil fuels? And it talks about global warming. This is the #1 gas we hear about. It's carbon dioxide. Carbon dioxide is the primary pollutant that's driving global warming. So that does it for our first standard. Our next one is talking about how the sun transfers heat to air, to land, and to water at different rates. And it specifies we've got to talk about transfer through conduction, convection, and radiation. So our first definition, the internal energy of a substance based on the kinetic movement of its molecules. And as a hint, this is the energy that's given to us by the sun. We call that heat energy. Heat energy is literally the vibration of molecules. Now, what do we call the amount of heat energy that a substance can hold? We call that the heat capacity. And remember, capacity is like volume. So if you have a large volume, you can hold more stuff. If you have a small volume, you hold less stuff. If you have less stuff, you fill up faster. If you have a large volume, you fill up slower. So things with large heat capacities heat up very slowly and cool down very slowly. Small heat capacities heat up quickly, cool down quickly. What do we call the method of heat transfer through direct contact, such as by touching? This is conduction. During conduction, it travels through solid. Heat energy travels through solid and into things that are touching that solid, such as here the hand touching the solid or the air molecules that are directly touching the rod. What do we call the method of heat transfer through changes in density, in which warmer things float and cooler things sink? Yeah, we've been talking about this for most of the year now. It's convection. Hot things rise, cold things sink. And when it does, it creates this cycle, a current, like a convection current, like we saw in the mantle. We see these in the ocean. We also see these in the air, in the atmosphere. That's how air circulates. This is actually what causes wind. So what do we call the method of heat transfer that occurs through invisible waves called electromagnetic waves? As a hint, this is how the sun's light reaches us on Earth. We call that radiation. Conduction is traveling through solids. Convection requires some kind of fluid to flow. So liquid is a fluid, air is a fluid. Radiation doesn't require any matter. It happens through the vacuum of space because it does not require a substance. What do we call the specific conditions of the atmosphere at a certain place and certain time? We call that weather. So when we're talking about weather, we're talking about the momentary condition of the atmosphere. Weather changes from place to place, from hour to hour, so we have to be very specific when we talk about weather. Now, what do we call the general conditions of the atmosphere that occur in a region over at least a 30-year period? It takes at least 30 years to change the climate, to determine the climate. And so climates creates things like deserts, and if you're a desert, you kind of stay a desert, right? It creates forests, and if you're a forest, you kind of stay a forest. Unless, of course, man comes down and chops down the forest, but people are bad that way. So here's our next one. We're talking about how, again, climate and weather. Now we're talking about how unequal heating of the Earth, as well as the rotation of the Earth, causes local and global wind systems. Local winds we talked about before the break. Global winds we're talking about now after spring break. So first, what do we call the movement of air through the atmosphere? It goes from areas of high pressure to areas of low pressure. That's what wind is. Wind is flowing air. And wind always blows from high pressure to low pressure. The high pressure pushes it into the low pressure areas. What do we call the ratio of mass per volume? It's the amount of matter in a certain space. That density, we've been learning about it all year. That's what causes convection, right? And wind is a convection current, like we said. The amount of stuff you have in you is your density. So this is low density. This is high density. Now, what do we call that air that has a low density? And as a hint, it's created by warm temperatures. Warm decreases density, which is why hot things float. We call this low pressure. Low pressure air is warm air. Particles are moving faster, so they spread out. Now, on the flip side, what do we call high density air? It's created by cooler temperatures. Yeah, high density, high pressure. There's more molecules in a certain space, so they're all pressing against each other harder. Now, the pressure differences are what drives wind, but what happens when those pressure differences are caused by regional, local differences in heat distribution, such as between the temperatures of land and water, creating different pressures above land and water? We call those local wind systems. And then what about differences in temperature across the world, like the difference between how the equator is hot and the poles are always cold? These are always the case. This doesn't change day or night. The equator is always hotter. The poles are always colder. We call these global wind systems. Global wind systems. So here we're talking about a local wind again. This is a local wind that occurs in the daytime when air blows from the ocean towards the shore. We call that a sea breeze, like we see in the top picture here. The land heats up faster than the water, so when the land is hotter, it's relatively warm. When the water is colder, it's relatively cool, so we have higher pressure sinking down, lower pressure rising. As the lower pressure rises, it branches out. As the high pressure sinks, the high pressure pushes into that low pressure area, and it creates a breeze from the ocean to the land. We're looking at the part down here where we live. This is called a sea breeze because it comes from the sea, from the ocean. Now, what do we call the nighttime local winds, in which air is blowing from the land towards the ocean? We call this a land breeze. The land breeze blows from the land, and that's what we see over here in this nighttime picture. We have relatively high pressure over land because the land gets colder at night. The land cools down faster than the water cools down, so the water stays a little warmer, a little lower pressure. The land gets a little colder, a little higher pressure, and that high pressure moves into the low pressure area. Now, in a region, what do we call the general winds, the most predominant, most common winds in an area? And as a hint, these are caused by global wind systems. And we said global winds don't really change that much. So these are called prevailing winds. In general, over the United States, the wind blows in a certain direction because globally, that's the direction the global wind is blowing. Weather can make wind blow in different directions, of course, but here we're talking about they tend to blow in a certain direction. They tend to blow in a certain direction. They tend to blow in a certain direction. And it's all dependent on latitude, like we see here. Now, what do we call those prevailing global winds that cover most of the United States? As a hint, they blow from the west to the east. We call them westerlies because we always name winds based on where they're blowing from. If they're coming from the west, they're westerly winds. If they're coming from the northeast, they're nor'easter winds. Now, these are the three words we didn't cover before the break. What do we call the curving of global winds that occurs due to the rotation of the Earth? We call that the Coriolis effect. Coriolis is some French guy's name, I think. So essentially, it's always colder, always higher pressure at the poles, always lower pressure near the equator. So you would expect the air to flow directly from the poles to the equator. But the Earth is spinning. So as it moves downwards, it actually gets pulled to the side as the Earth continues to spin past it. Likewise, if we were going in the opposite direction, again, the Earth is pulling the wind to the side because of its rotation. So because of the rotation of the Earth, the winds never go in a straight line between the equator and the poles. They always have to curve to the side. And it goes completely horizontal every 30 degrees. So 30 degrees, 30 degrees, 30 degrees, 30, 60, 90. We have a different wind pattern. We have a different circulation. What do we call the fast-moving air currents that circle the globe a few miles above the Earth's surface? We call these the jet streams, and they tend to happen in between the circulation cells, in between those global wind belts. There's a major one, this polar jet stream that covers the United States, and if you live in the Midwest, it's constantly coming down, bringing cold weather there. So people in the Midwest pay a lot of attention to these jet streams. And finally, what do we call those huge global wind belts created by convection and the Coriolis effect? There's 3 of these in each hemisphere. We call them circulation cells.